Hold on. Let me go to my favorites. I've got something called Big Ideas. Is this where it shows you the picture of the Algebra 2 textbook?
No.
Really? Well, I don't have it saved. So the only way I can get there is if you send me to it. And that's what, do you know how to copy and paste it into the GoToMeeting? Open up the GoToMeeting window.
Well, if I'm on a tablet, does it? Because I think we did this last time.
I don't use a tablet regularly, so I'm not sure what the difficulties are of you copying and pasting a URL address into the tablet. I suspect you can do it because I've never had anybody that can't do it.
Can I just email you the link?
Do that. That's fine. Yeah. If you can do that for sure. Doesn't have to be through GoToMeeting. Tell me when you've sent it. Do you have my email?
Yeah. It just sent.
That's right. Aussie 25 Phillips. Were you born in Australia?
Yeah.
That's one place in the world that I've always wanted to go and never have been. It's just too far away. It's a long trip, isn't it? To go from Australia to the US? All right, where do we want to start here?
83.
All right. Usually when you have 3 equations and 3 unknowns, there's a very specific method that you solve it with, but sometimes they give you a little bit of a break, and you don't have to use that harder method.
Okay.
This is one of those. In other words, we can take this right here and solve for both x and y.
Yep.
Let's do it. And you'll see why this is so much easier than the typical 3 by 3. How do I solve for x and y? What do let's label that equation 1 and that equation 2.
Okay.
How do I solve that system of 2 equations and 2 unknowns? You can do it. You have 2 choices. You can do it by substitution. You can do it by elimination. First of all, make that choice. Which one are you going to use?
Elimination.
Yeah, because it's in standard format. In other words, you got all your x's and y's on the left, you got the number on the right. Elimination's almost always going to be easier. Okay? Well, as the 2 equations stand right now, you can't get anything to be eliminated. And your only choices are to add the 2 equations together, but you also have a choice that you can multiply either of the 2 equations by a constant on both sides of it. So what can we multiply one of these equations by such that then when we add it, something will go away?
Could we do...
Give you a hint. Do equation 2. What do I have to multiply equation 2 by?
2.
Okay, that makes it 4x minus 2y equals minus 14. And the only thing you have to make sure you do is multiply both sides of the equation.
Yep.
Now I've got a different equation 1 and 2. Actually, equation 2 is the same as my original one. I just multiplied everything by 2. But notice that now what happens if I add equation 1 to equation 2? You eliminate one of the variables. And it doesn't matter which one. Your goal is to eliminate one of the variables. Well, we're going to eliminate y. So what's the resultant?
Would it be 5x equals negative 10?
So now you got x equal minus 2. Now you got to solve for y. Which equation are you going to use? My original number 1, my original number 2, or the new number 2?
Original number 1.
Yeah, that is by far the easiest one to use. For one thing, the x, they're all small numbers, they're all positive numbers. That's a good clue to look for. The smaller numbers and the more positive signs you see, choose that one, as opposed to anything that might have fractions or a lot of negative signs. So solve for y. Tell me how to solve for y. If I know x is minus 2.
Would it be minus 2y?
Hold on. All you're doing is starting off by plugging in minus 2 for x. We just solved for x.
Okay.
There's no longer any question as to what x is in all three of these equations.
All right.
What we have to solve for is now y. And once we solve for y, we're going to be able to solve for z using the third equation. But we got to do them one at a time. Okay? Now, if you solve for x, you plug it in to any of the three equations, well, any of the first two, and that will allow us to solve for y. So this gives us minus 2 plus 2y equals 4. Solve that for y.
Negative 1.
I get positive 1. I get 2y equals 6. In fact, I get y equals 3. Remember, when you move this negative 2 to the other side of the equation, you have to change it.
Yeah. Okay.
That's a frequent mistake I see students make, especially the way I do things. In other words, I don't do it the way your class does it. The way they taught you to do this is you add 2 and you add 2. Then you can't make the mistake. But to me, that's an unnecessary step. I really don't like to think that. What I have is when I have a plus b equals c, if I want to move that a to the other side of the equation, I do it and just change its sign. One step, not 2. Okay? But there's a danger in doing it this way. An awful lot of people move it to the other side and leave its sign the same. In other words, they make exactly the mistake you made. They subtracted 2 from both sides instead of adding 2. But anyway, now we have an answer for y. We know what x is. How do we solve for z?
Do you just plug them both into the last equation?
Do it.
So it'd be negative 2 plus 3 plus z equals negative 4.
Now, what does that make z equal to?
So
Let me give you a hint. Not a hint, but I want to give you a technique for handling this situation. Because there's three numbers that you have to combine, it's easy to make a mistake. So let's combine those two first. In other words, let's do it in 2 steps, not 1 step.
Okay.
What are those two combined?
1.
Plus 1.
Yep.
Now, how do I get that 1 to the other side?
You subtract it.
Okay. So what's the other side become?
So it'd be z equals -5.
You got it. And there you have all 3 solutions. Now, despite how long this took us, this was an easy 3 by 3. A really easy one. When you have 3 by 3s where each equation has all 3 variables, there's a whole different technique for solving it that we didn't have to do once here. What we really had to do was solve the 2 by 2, which is an elementary problem. You got to know how to do it, but it's still easier to solve a 2 by 2 than it is a 3 by 3. But once we solved it, now we had x and y, and we only had one equation we had to plug that in for. So this really was not a 3 by 3, despite what it looks like. It looks like a 3 by 3, but at no point in time do we have to use the method that you would normally use for 3 by 3. We'll see if they give us one. No, they may not give us one. That's a true 3 by 3. Which is fine. Those take about 15 minutes to solve because they're such a lengthy solution. All right, so let's express the solution algebraically, meaning solving this inequality. And then let's graph it on a number line, just a one-dimensional number line. So in number A, what's the first step? Tell me what the... Actually, just keep reading successive lines to me. I don't even care if you tell me how you do it. Just tell me what the next line is.
Would it be... would you factor it?
No, there's no factoring there.
So
remember what we're trying to do. We're trying to solve for x. Whenever you have an equation and there's one variable in it, and that's what you're trying to solve it for, which is always the problem. That's all math problems, all equations are like that. If it's a single variable, you're trying to solve for that variable. So you got to get rid of everything that's attached to it, beginning with the stuff that is being added or subtracted, ending with the stuff that is being multiplied. That's the method for solving equations. So what do I got to get rid of first?
The -5.
Okay. Read the next line.
So 3x is less than or equal to 12.
Okay. And the next line.
So then do you divide it by 3?
Yep. Be more confident that that's what you do.
Okay.
I want you to learn that. I want you to believe it. And I want you to believe you know how to do it. So don't say, do you do this?
Okay.
I want you to have a more confident attitude where you know how to do it. You tell me how to do it. If you're wrong, I'll say, no, in this case, there's another way to do it. But I'm not going to criticize you. I'm not going to come down hard on you. Just tell me what the next line is.
So you divide it by 3, and then x will be greater than, or x is less than or equal to 4.
Okay. That's the answer. Now let's draw that on a number line. This time I'm going to put 0 on there just for a reference, and I'm going to put 4. How do I graph that?
You test something greater than 4?
No, in this case you don't have to do that. We got the exact answer already. So how would that graph? Where would I start? Would I start at 0? Would I start at the number 4? Where would I start?
You'd start at 4, right?
Yeah, with a solid dot or an open dot?
It'd be open.
Actually, open would be if it was just less than. But since it's less than or equal, in other words, if you have the equal sign along with the inequality sign, it's always a solid dot.
Okay.
And which way does my line go? To the right or the left?
To the right.
What's less than mean?
Oh, so it's going to be to the left.
It's always dependent on the direction of that sign. You put an arrow on it because it goes all the way to negative infinity. In other words, my solution set is negative infinity to 4. And in fact, if I wrote it in interval notation, what would it be?
So it'd be negative infinity, comma, 4.
Parentheses or bracket?
Parentheses.
Bracket in this case. Why? The bracket means it can be 4. The parentheses means it can only approach 4. So if this problem had just a less than sign and not a less than or equal sign, then it would be a parentheses. But because it's got a less than or equal, it means it's okay. X can be 4. Yes, that's an allowable answer. That satisfies that equation. X being 4 does.
Okay.
That's the difference between parentheses and brackets. Now, before we hop on to the expert slope on number B, let's talk about, notice something else. Notice that I solved this inequality exactly the way you would solve an equation, right?
Yeah.
Nothing different. I added 5 to both sides, then I divided both sides by 3. Everything looks exactly the same, except I got this thing that's not an equal sign. It's a less than or equal sign. Well, there is one time, or not one time, but there are things that if you have to do to the equation, like multiply or divide by a negative number, then you got to switch the direction of the sign. For example, let me give you a problem. Minus x plus 2 equals 10. First step. Oops, greater than 10.
So do you subtract 2? So you subtract 2 first.
Give me the next line.
So negative x is less than 12.
Yeah, because all I did was subtract 2. I didn't multiply or divide by a negative number. It's not when you add or subtract numbers. It's when you multiply or divide by a negative number. So the next line is that.
Okay.
Now I got to get x all by itself on the left side. How do I do that?
Do you add x?
No, that would make the left side 0. And it would, yeah, actually that would get to the solution, but that's not the way to do it. You want to divide both sides by -1.
Okay.
In other words, I want to divide that side by -1, and I want to divide that side by -1, and that will leave me x all by itself.
Yeah.
But because I just divided by a negative number, I got to turn the direction of the inequality around.
Okay.
So the true answer is x has to be less than -8.
Yeah.
The only way to get that is to follow that set of rules. And just remember that you have to multiply or divide. It's not about adding and subtracting. You can add and subtract all you want without changing the direction of the inequality. But you cannot multiply or divide, or it turns out take square roots. Tell me the next line here for B.
So you'd factor,
Nope.
and it would be
Nope. Nope. Well, not really. That'd be the hard way to do it. There's really a much easier way to do it. And let's do it the easy way before we go back and do it the hard way.
All right, so subtract 6.
Okay, so that gives us x squared is greater than 36.
Yep. And then you would square root it.
Okay, and here's taking the square root is very similar to dividing or multiplying by a negative number. You get, notice if this was an equation. If I had x squared equals 36, you tell me the answer. What's x equal
to? X equals 6?
Nope, plus or minus 6.
Okay.
Okay, always. Every time you forget the plus or minus, you're losing points on your
All right.
Okay? I wish I had a way of getting people to remember that plus or minus. That's the most common mistake I deal with in all levels of math, is people forget the plus or minus. Okay? Well, the same thing is true over here, only the answer ends up being x is greater than 6 or x is less than -6. So I still have my plus or minus, but I have to change the direction of the sign. And if you look at this makes sense. If x is greater than 6, let's say x is 7. Okay, well 7 squared is 49. 49 is greater than 36. So that definitely works. Now let's look at this one. If x is less than -6, give me a value where x might be less than -6. Give me a number that is less than -6.
-7.
Okay. Now if I square -7, what do I get?
If you square what?
-7. Don't do this on your calculator. Please.
You get positive 49?
Exactly. -7 squared is plus 49, and that's also greater than 36.
Yep.
So either one of these solutions works. And this one goes from -infinity to -6, and this one goes from 6 to infinity. So you can write it as a interval notation if you need to. But the key thing is that the only differences I've discovered yet, absolute value also presents a little bit of a problem. How to handle absolute values and inequalities. But mainly the things you have to be careful about, I can't believe they didn't give you a problem showing you this, but you can't divide or multiply by a negative number without changing the direction. And when you take the square root of both sides, you have to make it greater than the positive number or less than the negative number. Okay?
Okay.
All right, let's go on. So we have 3 red rods. And we have 2 blue rods. Let me see. The red rods are 2 centimeters longer than 2 blue rods. I don't like their language already. Here's 1 blue rod. Here's another blue rod. If we're going to solve this using algebra, it's a word problem, right?
Yeah.
So we probably have to come up with an equation that matches the paragraph. The first step, always in a word problem, is to define your variables. And the way to do that is always look to the last sentence. How long is each rod? So give me some variables and what they mean. Always don't pay attention to anything but that. How many variables are there going to be?
2.
Okay, let's let x be 1 and let's let y be 2.
Okay.
Or y be the other variable. Now tell me what x is. When you define your variables, I mean, what does x mean? Just you can't say x is the red rod. It's not. What is x?
X is 3 red rods.
A length of each red rod. Length of each red. And if you spell it out, you cannot make a mistake. If I just said the length of the red, you wouldn't know whether it was the length of all 3 reds or the length of each rod. We got to let it be, remember what the last question says. How long is each rod? So we don't want to let x be the length of all 3 of them. We want x be the length of each one. Now tell me what y is.
It would be the length of each blue rod?
Okay. Now let's turn these into some equations. In other words, a word problem, you always start at the end to figure out how to define your variables, and then you go back and you do the problem starting from the beginning. So tell me how to put that, using our variables, put that in an equation.
So 3x.
What can I use for the word r?
Equals?
Whenever you see r or is, that usually means an equal sign.
2 plus 2y?
Perfect. Now give me an equation for the second sentence.
So 3y equals 2 plus 4x.
Now what we have is a system of 2 equations and 2 variables. They're independent of one another. One is not just a multiple of the other. And we know how to solve that. We can solve it by elimination. We can solve it by substitution. How should we solve this one?
Elimination.
I'm a fan of elimination, even if it isn't given to you in standard format. So take equation 1, and first of all, give it to me in standard format.
Would it?
By standard format, it means get your x's and y's on the same side in that order, x first, y second, and get your number on the other side.
So you'd have to subtract 2y?
Okay, just give it to me, yeah.
So 3x minus 2y equals 2.
Okay, that's one equation. Do the same to the other, putting it in the same standard format.
So 3y minus 4x equals 2.
You got the y in front. We don't want the y in front.
Oh.
Got to get, in order to eliminate these things, they need to be lined up. So we don't want one equation to have y in front, x in second, and the other one to be vice versa. Standard format means you put the x first, the y second, and the number on the other side.
So minus 4x plus 3y equals 2.
Okay. Now, even though we want to use elimination, this is not that easy to use elimination on, because I cannot multiply just one equation by anything and be able to eliminate a variable. But I could multiply both equations by something. What should I multiply equation number? Remember, the goal is to get two equations where one variable disappears when I either add them or subtract them.
By 2?
Well, I got to multiply each one by a different number, which is okay. The rules of algebra say you can do anything to the left side of an equation as long as you do it to the right. So yeah. What if I multiply the top one by 3 and the bottom one by 2?
Okay.
Notice that I would have 6y, I would have minus 6y and plus 6y. That's what I'm looking for. I could also multiply the top by 4 and the second one by 3, and I would have 12x and minus 12x. But I'd rather deal with smaller numbers. So 2 and 3 are smaller than 3 and 4. So I'm always doing this technique. If I have a choice, and I don't want to deal with fractions. Now, could I use fractions? Yes. I can multiply the top by 1.5. Okay? Unfortunately, when I multiply the number 3 by 1.5, it turns it into a fraction. And that complicates solving equations when you got fractions. You don't want fractions. You want whole numbers. So multiply the top by what? And give me what the new equation 1's going to be. It's like finding a common denominator. My common denominator is going to be 6. Okay?
Yeah.
That means I got to multiply the top by 3. And I got to multiply the bottom by 2 in order to produce 6.
So it'd be negative 9x.
No, I'm not multiplying by minus 3. I'm multiplying by 3.
Oh, yeah.
I'm going to do this. I'm multiplying by 3. And I got to multiply this by 3. And that'll turn that into a minus 6y. And I want it to stay minus, because I want to add these two equations to eliminate a variable.
Yeah.
So it's 9x. Keep going.
Minus 6y equals 6.
And now the second one, what do I want to multiply it by?
2.
I meant to put that there. So read it.
So it would be negative 8x plus 6y equals 4.
Okay. Now, you can, incidentally, add or subtract equations. So if these y terms both had the same number in front of them, I could still deal with that. I would just subtract them instead of adding them. But most people handle addition a lot better than they handle subtraction. So it's really usually better if you set these things up so that you're going to add the two equations. I'm going to add 1 to 2. What do you get?
1x equals, what are you supposed to do with the last one?
Add the two equations. When you add two equations, you add all parts. You add the left sides together and you add the right sides together.
So it'd be 10.
Okay.
So x equals.
So we found the length of each red rod. Now, if 3 red rods are 2 centimeters longer than 2 blue rods, what are the lengths of each of the blue rods? And you can get this by looking at the picture and figuring it out in your head, which isn't that hard to do. Or you can just substitute x equal 10 into either of these original low number equations. Let's do it the other way. Let's do it this way here. If 3 red rods are 2 centimeters longer than 2 blue rods, what are 2 blue rods? What are their length?
Would it be 28?
What's each blue rod?
14.
There you go. And now let's see if that satisfies the second condition, just to check it. 3 blue rods, which would be 3 times 14, 42, are 2 centimeters longer than 4 red rods, which would be 40. So that works also. So we basically checked our two premises. We solved it algebraically. Everything checks. I would now bet my life that we got the right answer. In other words, I've done everything I can possibly do in my power to figure out the answer, and everything checks. When I say bet my life, that's kind of what I mean. Not that I would ever bet my life on these, but it has to do with having a certain degree of certainty. I was 99.9% certain of those answers after checking them all. All right, hold on a second. Let me read this one. Okay. Over here, I'm going to draw it one way, and over here, I'm going to draw it the other. First of all, how do I graph it?
Graph what?
How do I graph this right here? Two steps to it. First step is to graph it as a straight line. If I was going to graph that as a straight line, how would I do it?
Would you go? Huh?
Where would I start?
-2.
Okay. How would I find a second point, which is all I need? 2 points make up a straight line. So all I got to do is find one more point and I can graph this thing.
Would you go up 1 over 2?
Slope is rise over run. You got to go up 2 and over 1.
Yeah.
It's 2 divided by 1. It's not 1 divided by 2. Okay? Not only that, but I got to make sure my slope is positive. So it's not really sufficient to say up 2 and over 1. You got to say which way over. To the right or the left?
To the right.
Okay. So I'm going to go up 2 and to the right 1. So that's my second point. I can draw a line between those 2 points. In this case, should that line be dotted or solid? Again, what it has to do with is that sign versus that sign. One is a less than sign, the other is a less than or equal.
So it'd be solid?
Difference, yes. That's a solid line. Same 2 points in blue. Exactly. But in blue, is that going to be a solid or a dotted line?
Would that be a dotted?
Now, there's one part left to both of these problems, and that's which side to shade. She does not know, well, that's not what this question says, but that's a key part of these. You have to know which side of that line we're shading. Which side is it? On both the left and the right, it's the same. And I want your answer to be above or below, not left or right.
Above.
What's that say?
Less than or equal to.
So which side should we shade again?
So below.
Okay. You always look to the y-axis, always. Because it's always y is all by itself over here. In all your equations, it's y is less than that line. So as all you do is you find a point on the y-axis that's below that line. I could pick that point, I could pick that point, I could pick that point. That tells me which side to shade. And notice why I don't say, never say left or right, or why I said that, is because I don't want you to say to the right. That's not the way to describe this. It's below, based on the fact that y is less than that line. Same thing with the blue line. Y is less than that. This one was y is less than or equal. This one is less than only. The only difference is the solid line versus the dotted line. In terms of which side to shade, I look to the y-axis. I find a point less than the line. I could pick that point there. That tells me I got to shade that side right there. The only time that you look left and right is when it is a vertical line. In other words, if, and that is the only time, if I have a vertical line whose equation is x is greater than 5, well then I'm going to shade to the right because top and bottom doesn't make any sense on a vertical line. But any other line that has slope that's not vertical, you're always answering above or below, even if I have the following situation. That is, y is less than 100x, that equation right there, that inequality. Which side do you shade?
It would be below.
Perfect. So many people would want to say right. And right happens to be correct here, but I don't want you to look at that. I want you to look at based only on the y. All we have to do is find a y point that's below that line. That one is, that one is, that one is. That tells you which side to shade it. Now, some people would say that's to the right, but it's very important that you treat it as whether it's above or below. Except if it's a vertical line. That's the only time it's acceptable to say right or left. All right. Let's see if we can get one more in here.
So our teacher said to skip 87 and go to 88.
Okay. So what they're saying, what's the equation of the x-axis? In other words, if I had a line like that, and they're not talking inequalities, so I really should make that a solid line. What's the equation of that line?
X equals 0?
No. X equals are vertical lines. Y equals are horizontal lines.
Oh. So y equals 0?
Y equals 0. Sure. If I had a line like this, you'd say that's y equal 1, right?
Yeah.
If I had a line like this, you'd say that's y equal -6. So it just because it's going over the x-axis doesn't mean it's x. That's y equals 0. What's the equation of the y-axis?
Where?
The second part of that question. What's the equation of this y-axis?
So it'd be x equals
What is x equal to right there?
0.
You got it. It's equal to 0 everywhere on that blue vertical line. Every single point from -infinity to infinity, x is equal to 0. Just like every point on this horizontal blue line, every single point, the y-coordinate is 0. I can go from -infinity to +infinity, and the y value is always 0. That's what that means. Just remember that the x-axis is y equals 0, and the y-axis is x equals 0. In other words, it's always the opposite of what your first inclination is. The mistake you made is one that almost every student makes. They want to call the x-axis x equals 0, and it's not. All right, Lachlan, I will let you go, and you have a good rest of your Thanksgiving holiday week, and a nice Thanksgiving.
You too.
Yeah, thank you. I'll probably talk to you next week or the week after, whatever.
Yeah.
Talk to you then. Bye-bye.
All right, thank you.
Mm-hmm.